Okay, this is part two. I'm going to do some more problems. Again, I apologize, my input device is broken, so I'm going to be using a mouse to write, so it'll take a little longer and be a little sloppier. But as mentioned in the first video, all of the completely worked out problems from every worksheet is on the drive. Please refer to those documents and use them to check your work. Okay, this is problem 6 on, I think, 9-R. A square based pyramid. Okay, I've taught you, one of the things I've taught you to do is always underline. So square, meaning we know this base B is a square here. Has a base area of 36 meters squared. The red line, the slant height, has a length of 5 meters. What's the volume? Okay, so the real trick is the base area is already given to you, right? So the volume formula for pyramid and cones, right? Anything with a point, anything comes to a point, anything pointy, is 1/3 the base area, which you already know, times the height. And the height is the real mystery here, right? That's the big mystery. What is the height? Because the height, I'll color code it here, is this dotted line here, right? H. You can see it right there. Okay. And it's not told to you. So we're going to use this information of 36 meters for the base area. Now this is a square. So we know that something times something that's exactly the same equals 36. Well, that sounds distinctly like the square root, which it is. In other words, what two numbers multiplied by themselves, right? Because they're the same. Like, in other words, whatever this is, x, this is x, right? These two sides right here and right here have to be the same because they told us it's a square base. See? So we know they're both 6. I mean, you can do square root of 36 on your calculator if you need to. You can write x squared equals 36, which is the formal way of doing it, x times x. X squared equals 36, and then square root both sides. It's not that tough to figure out that this is 6 and 6, okay? Now, that's important, but really what we need is this. See, we need one of the sides of this right triangle here, right? We already know that this is 5. I'll color code this red. So this is 5 right here. All right, that's the slanted height here. Pyramids and cones have a slant height. So that's 5. And this piece under here, I'll color code this purple, from here to here, goes from the edge to the center. Now, if you were to keep going all the way across, it would be the full length across, which you know is 6, see? So that makes this little piece in here, that little piece, which is half of it, because these right pyramids, the center of the pyramid falls directly over the center of the base. And it's the only ones we're going to give you, so you don't have to worry if that doesn't happen. So this is equal to 3. It's half of 6. So if you take this triangle, we actually move it out of the picture. I don't think it's going to be isosceles. I don't think that's going to work. Yeah, I need this one here. All right, so if we were to take that triangle like this, rotate it about, see? And put our right angle. So I'm just copying this triangle over here from the picture. I was making a separate picture to help myself. That's one of the techniques we've talked about all year long, which is sometimes it helps to draw things, either if they're not drawn at all, to draw them, or if they are drawn but not at a good view or involved in a complicated other picture, to simply pull it out, just the part that we need, and that would help us. So see if I give you this in a test way back from unit 4 or 5, I think it was unit 5, triangles, you could easily solve this, right? And of course we talked about triplets in the first video. We talked about triplets every day in class. 3 blank 5 means this must be a 4. You can of course do Pythagorean Theorem. All you need to do is put 5 squared equals 3 squared plus b squared. Solve it for 4. But we've done 3, 4, 5 triangles so many times. It's critically important for efficiency that you memorize that. All right, so it turns out that the height is 4. So we got all that from the area. The area helped us with that, as did this 5 for the slant height. Okay, and that's it. We're just going to multiply everything together. So a third of 36 is 12. 12 times 4 is 48, right? So V equals 48 meters cubed. Don't forget the units. You're going to lose a point. I think we only took a half point off last test. We're going to take a point off this test because we've done it so long. Okay. All right, we did this one a lot in class. I'm just going to really briefly do this one. But what happens when we take something like this? Now, this has a surface area, and they didn't give us an R, right? They didn't give us an R. So I'm just going to use the formula of 4 pi r squared. Surface area, see? So that's the surface area of this figure. When we cut it in half like this, we still have the same yellow surface area. See this yellow surface area? This yellow surface area together is the same as before, right? So the surface area of these two half spheres, or hemispheres as we call them, is exactly the same as before. We didn't lose any surface area. But we gained, and I'll color code this to match, right? We gained this area here, see it? I'm going to undo that because it's a little sloppy, but this blue area here and this blue area here. And that's one circle with the same radius, by the way. So this radius here is the same as the radius here, and 3D is the same as the radius here. It's the same as all the radii, though they didn't give it to us, so we're stuck with R, but it's the same R that we had here, see? So it's going to be two circles. So it's going to be 2 and then a circle, right? And a circle, of course, is pi r squared. Okay. You don't really need any advanced math to see that you added 2 pi r squared to a previous total of 4 pi r squared. That's 50% more, right? 50% more. So 6 pi r squared. You can do the math. You can put it in your calculator, of course. You can do for percent increase, which we've told you about. And I'm answering part A, B, and C all at the same time here, obviously, because we did this in class. So this increased by half of the original. In other words, you started with 4 pi r squared. You added 2 pi r squared. That's half of this, right? So that's a 50% increase, okay? It's 1.5 times as big as the original, right? This is an increase. I'm not going to write the word increase here, but I'm going to put INC, but you know that means increase. And it's, or I should say, it's saying the same thing as it's 1.5 times more. Not more, sorry. It's it's not 1.5 times more. It's 0.5 times more. It's 1.5 bigger than the original, right? Bigger than the original. You might also say, and it would be correct to say, it's 150% of the original. It's 150% surface area compared to the original, which means it went up 50%. So in other words, it's the same size, it's the same 4 pi r squared, plus some more. That's a 50% increase for a total of 150% of the original. So wording and grammar makes all the difference when being asked a question in math. You have to understand, are they asking me how much more is it? Or are they asking me how much is the new one compared to the old one? So these three are all true. It's a 50% increase, it's 1.5 times bigger, and it's 150% the size of the old one because it starts off as the same size and then increases by 50%. Okay. Let's go to this coin. Now, the only confusing part about this coin is a very straightforward problem. Two things that are confusing. One is it's a cylinder, and a lot of students didn't realize it's a cylinder. It's a very flat cylinder, right? So in other words, I think I have a cylinder in here. No, I don't. I think I do. No, I don't. Okay, so it's a cylinder that's been shrunk down so that the height is very small, okay? And the other difficult part is that you only want the silver part. So you only want this volume here, see? So we're basically going to do what Dunkin' Donuts does and create an entire donut and then cut out the middle. Of course, this munchkin would be huge, this gold part or bronze part probably. So we're just going to take the whole coin, and then we're going to subtract, which is a cylinder, and then we're going to subtract this inner coin, in other words, everything inside this blue line here, right? All of this. We're going to subtract all this out of it. So basically, we're going to find the volume of two cylinders and pull the inside one out of the original, right? The whole. So the volume of the whole, let's say W for whole, W-H-O-L-E. So the volume of the whole thing, the whole picture, is, of course, pi r squared h, right? So pi 11.5. Now this is giving you questions in decimal, so we're going to stick to decimal, which I know we rarely do. Pi r squared h. Okay, but it is a decimal problem, and they should have said, if this was on a test, we would have written round to the 10th place, okay? So we'll add that here, 10th place. It might not be rounded, and it actually might work out to be a perfect answer, I don't remember, but it might not be rounded to the 10th place on the solution guide because it's not written here, so I'm kind of changing it a little bit, changing the problem. But on a test, given a problem with this much decimals, you'd be asked to round to the 10th place, not to give it in terms of pi. But I'm assuming on the answer sheet it's probably in terms of pi. So we'll do it a little differently, which is good. And so if you haven't done that, try it now, right? So try this in your calculator and see what you get. Okay, pause the video and do that, all right. So I'm going to take 11.5 squared, which is 132.25, times 2.2. And then I'm going to do times pi. And pi on my calculator is the second function of that little up arrow thing. If you look below the clear key on your calculator, take out your graphing calculator, look above the divided by key or below the clear key, right on the right side there. There's a pi symbol. So we're going to press the blue key second, and then pi. And I think the answer is 914.05. So it probably is in this form on your solution guide. 914. And I'm rounding it to the 100th place here because if I want 10th place accuracy, I better keep at least 100th place here. Okay, and then the volume of the inside, or the bronze, I could have done B, maybe bronze, but of the inside cylinder is the exact same formula, of course. It's just we're going to use a different radius, right? So this is going to be 8.5 squared times the same height of 2.2. Sorry, it's a little sloppy. And I was going to put that in my calculator, so 8.5 squared times 2.2 times pi, which is second up arrow. And I get 499. I really should have units on these, even though they're not the final answer. 499, excuse me, 0.36. Okay, and then my answer, right? So the volume of the silver, of the S, silver, I know it looks like 5, but it's supposed to be S. The volume of the silver is equal to the whole picture, right? 914.05 minus the inside. So I'll do that on my calculator. 914.05 minus 499.36. Notice there's no pi symbols here because we're doing the whole problem in decimals. And the final answer to the 10th place, again on the solution guide they may have done a different place, 100th place or something, or integer, but 4.1469. So I'm going to round that to 7, and I'm going to put my units here, which is millimeters cubed. Okay. You probably should have millimeters cubed here and here. It doesn't really matter because as long as your final answer has it, that's all we're going to check. But if that helps you, that's great. Okay. This guy's pretty easy. It looks really tough at first, but really this air, right, because it was cut away here. I think the metaphor I used in class was imagine you're eating lunch at the lunch table with two friends next to you, and right before you take a bite of your square sandwich, right, although this is not square, but rectangle sandwich, let's say, your friends take 2 bites out of either side, okay? And this volume, in other words, all of this air in here, see it? All this air in here, and all of this air in here, they're both half cylinders, but there's 2 of them. So really, all you're doing is taking the volume of a prism, a rectangular prism, minus the volume of a cylinder, okay? So let's do that. So the volume of the prism, the rectangular prism, is just base area, which is 10 times 6, right? So base area, 10 times 6. You could just write 60, but I'm just showing you where everything's coming from, times the height of 4. Okay? And that is 60 times 4, which is 240, right? So this is 240. And there's no units here, so it's units squared. I'm going to leave it off, though, for speed's sake. And then the volume of the full cylinder, right? Of the full cylinder, because these are really 2 half cylinders. And remember, the radius is half the diameter. So if it's 6 from here to here, which it is, in other words, all the way across is 6, then that red segment, the radius, would be 3. Okay. And the volume of a cylinder is the same thing, base area times height. Base area times height, only the base is, of course, a circle. So pi 3 squared base area, pi 3 squared times height of 4. And notice we're going to leave this in terms of pi. This is not a decimal problem, right? At least they didn't indicate that. So 3 squared is 9, 9 times 4 is 36, that's 36 pi. So we can't mix these. These aren't like terms. One of them has a pi next to it, which is about 3, right? So it's really about 90, or actually it's more like 100 and something, 100 and change, right? This is 100 and something, and this is 240, okay? So the volume of this shape of the, I'll just put V. Volume of this shape with the air cut out is the 240 minus the air, and the air is 36 pi, so it's 240. Okay, and then we'll subtract the red, minus 36 pi. And believe it or not, that's the final answer, because these aren't like terms. We can't combine them unless it was a calculator problem, unless they said round to the 10th place. And this is at 6, sorry. 240 minus 36 pi. Of course, we need units, so we're going to group the whole thing for it. That's a pi symbol there, sorry. 240 minus 36 pi. And they didn't give us any units, so we're going to use units squared, units cubed, excuse me. So, and you could put u cubed. We would accept that on the test. That's a cubed. Try it again. Okay. This is a toughie. A lot of kids struggle with this one. Let's see if we can't do this now. I'm only going to make a 2-dimensional sphere, so it looks like a circle, of course, right? But it's supposed to be a sphere. Not that we really need a diagram here. I'll try to do like this kind of thing to show it's kind of rounded a little bit, like a pool ball, a cue ball. The sphere has a volume of 36 centimeters cubed. What's the surface area? Okay, so they told us volume and they actually gave us the answer. See, so we're going to use the volume formula, which you'll have on the test. This is going to be given to you, 4/3 pi r cubed. And we're going to replace the volume, we're going to place the V with the actual answer. In other words, it's a Jeopardy problem, right? They gave us the answer, so this is 36. Okay, so what is that going to do for me, right? Well, we can solve for R. There's only one variable in this equation, right? This is an equation. They gave us 36 pi. Excuse me, I forgot the pi. 36 pi, excuse me. 36 pi. You don't use, we're not going to put the units in for this work because we're going to do some algebra work. Okay, so we want to solve for R. So what we're going to do is, as you always know, anytime, first of all, this could be rewritten. I think this confused a lot of students before. It shouldn't, right? We've done this so many times. This is really Algebra 1, but we could rewrite it like this to make our lives easier, mentally anyway, right? Over 3. See the whole thing over 3. Just think of like 4/3 is a fraction times pi r cubed, which is, it's really not an integer, of course, but it's not a fraction, right? It doesn't look like a fraction. So we have to put that over 1, multiply across, and this is what you get. And that just makes it a little easier, I think, for students to see. So we can see what we're about to do. 36 pi. Okay, sorry for the straight line. Okay, what are we going to do? Well, whenever we have it, we want to isolate R. We want to get this by itself. There's a lot of things being done to R. It's being cubed. It's being multiplied by 4 pi, and it's being divided by 3. And we always want to go in reverse PEMDAS here. So we're going to multiply by 3. We always love to get rid of denominators. We don't like denominators. They make life complicated. Notice on the right side, I multiplied by 3 over 1, but on the left side, I multiplied by 3. Right? Which is the same thing. It's just there's no fraction over there. So 36 times 3 is 108. So this becomes 108 pi. And on the right side, the 3's are gone, right? 3's reduce. That's the whole purpose of doing it. So we're left with equals 4 pi r cubed, right? Okay, now what's being done to r? Well, it's being cubed and it's being multiplied by 4 pi. So reverse PEMDAS tells us do the multiplication, get rid of the multiplication first by doing the inverse of multiplying by 4 pi. So we're going to divide by 4 pi. Okay, now a lot of you forgot this in the last test. I think there was a similar type of situation here. Pi divided by pi is just 1, right? They reduce to 1. Okay, and if we put 105 divided by 4 in our calculator, we get 27. So we're left with 27, pi's are gone, equals r cubed. Okay, now this is an easy one. You're only going to get easy ones. But if you wanted to use your calculator to do this problem, which is going to be cube root both sides, right? To undo a cube, we have to cube root, not square root. It's called cube root. It looks like this, right? With a 3 there. And we're going to cube root 27. It will always be a simple one like this, so you really don't need a calculator. But if you'd like to use your calculator, this must be equal. If you'd like to use your calculator, and try this on your graphing calculator right now, after I tell you, pause the video, go turn your calculator on, press the math key, and if you go down to number 4 on most of your calculators, should be 4, and press enter, you'll get a cube root box right on your calculator screen, and you just type in 27 and then hit enter, and you'll see you'll get 3. But basically, you're just asking yourself what number times itself, right, twice, will give you 27, right? And you can always just make a quick table, right? You could always just say to yourself, all right, let me just write the first few. So 2 times 2 times 2, that could be an answer. 3 times 3 times 3, that might be an answer. 4 times 4 times 4. And we're not going to give anything higher than this, believe me. It's going to be one of these 3. And then you can just write the answers here and then figure out, oh, the middle one is 27, so the cube root of 27 is 3. Okay, we're not done. We're like, why do we even bother to do that? Why? Because they asked us to find the surface area. Again, this is the formula you'll be given. So the surface area, now that we know r, is findable. And it's 4 pi r squared. Pi r, that's 3, squared, is 9 times 4 is 36 pi. Okay, so it happens to be exactly the same, I guess. Units cubed. Oh no, centimeters cubed, my bad. Centimeters cubed. Okay, and just check the answer guide on the drive. I don't remember it being the same, but I guess it is, and I don't think I made a mistake, but I could have, so just check. Now, I know r is 3, and it's 4 pi r squared, so I think this is fine for the surface area. I'm sure it's the same. It doesn't always have to be that way. It just happens to be this way, that the volume matches the surface area. Okay, ice cream cone problem. I think we did in class. I'm not going to do this one. It's on the sheet. I'll just talk about it really quick, just because my hand is very tired from doing this. But basically, it's a half sphere, a hemisphere, plus the cone, right? Because there's ice cream also packed inside the cone. So you're going to do a full cone. The main mistake kids made on this was that the cone has a height of 12, see? Okay, and then the cone also has a radius of 4 from here to here, which is also, that's the radius to use for the hemisphere. To find the volume of a hemisphere, just take the volume of a full sphere and divide it by 2, add the volume of this cone, you're all set. It's all on the drive, very easy. Okay, I want to talk about this one because this was one that the kids really struggled with because you forgot your 36/90 rule. Okay, here is a right triangle, right? And you could use Pythagorean Theorem if you knew one of these other sides. You don't. So this leg, which is 4, is across from the 30, right? There's the 30. Okay, how do I know that? Well, it's 60, 90, and 30. The other thing that students didn't realize is that this is a prism, although it did say it's a prism here. It's hard to see it because it's on its side. We're used to a prism being vertical. But actually, right, this is a prism on its side, so it might help actually to put the letters kind of. So that's the height, right? And then this whole area is the base. See, this is one of the bases. Prisms have two bases, of course, right? And then the other base is over here. See it? See, bases are parallel to each other. That's how I know those are the bases. The sides are rectangles, right? As we've talked about for prisms, or at least for right prisms, which is the ones we're going to be working on. And the bases can be anything. They can be triangles, hexagons. There'll definitely be a hexagon on the test tomorrow, Monday, as we mentioned in class. Triangles, hexagons, they could be rectangles, they could be squares, it could be any polygon for the base. But the sides have to be rectangles. And the bases are parallel to each other. They're going in the same direction. None of the other faces, none of the other lateral sides are parallel to each other. So you know this is a prism laying on its side. All right? So the volume formula of all prisms is just base area times height. All right, well, what is the base? The base is a triangle. The height's easy. That's just 8, right? I don't know what this looks like. Yes. It's supposed to be the letter H on its side, okay? And how do you find the base of a right triangle? Many times we've done this, right? From previous units to unit 4 or 5, I think. It's always 1/2 the base times the height. And in a right triangle, even in a non-30, 60, 90, for example, 45, 45, 90, or a 3, 4, 5 triangle, in all of those cases, the base and the height are the legs. That's this red one there and this blue one there, not the hypotenuse, right? It's just the two legs multiplied together. Yes, there are other ways. You could use the hypotenuse as the base and you could find an area, for example, here, right? But it's a lot of work. It's not impossible, but it's a ton of work. No need to. When you know the legs of the triangle, you just use them for the base and the height. Now, I didn't write what this leg is, right? But it's a 30, 60, 90 triangle. This is the short leg. It's right across from the 30 here. So the blue one is the long leg across from the 60. And you should know this by heart by now. The long leg is 4 radical 3. Radical 3 times 4, I should say. Radical 3 times longer than the short leg, okay? So the volume is just 1/2 the base. We'll call that 4 radical 3. Actually, we'll call it 4. The order doesn't matter. And then times 4 radical 3. That's just to help me remember that the radical is actually the last term, right? Okay, that's a 3 in there. My apologies. So finally, the volume of this prism, which is the base area, 1/2 base times height, the little base, times the height of the prism, which is 8. And 4 times 4 is 16. 16 times 1/2 is 8. Can't multiply by radical 3, so I just leave it there. 8 times 8 is 64, right? So 64 radical 3. And I think that is centimeters. Yep, it is centimeters. Cubed. Okay, now surface area is just adding up all the shapes, right? Surface area is just adding up all the shapes. Again, we're not going to give you this formula. You should just know that. In other words, what I mean by all the shapes, all the sides, all the two-dimensional sides, right? This figure is made up of 2 triangles and 3 rectangles, right? Stuck together. Think of it that way. If you took pieces of paper that were cut out in those shapes, you could make a 3D shape. So all we're going to do for the surface area is add up, in this case, all 5 sides, right? In the case of a hexagonal prism, there'd be the 2 bases and 6 rectangles. That would be 8 sides. So they all vary. So I'm going to follow the formula that we taught you in class, which is there's 2 of these. These 2 are always the same. So there are 2 bases, right? 2 bases. And if you look up here, we can just kind of steal it. The base areas are 1/2 4 times 4 radical 3, which is 8 radical 3. So I'm just stealing it from up above. So that's 2 of the sides, right? Plus what? 3 rectangles. And you can kind of see them. I'll see if I can highlight them. Maybe that might work better. So there's this yellow one here, the slant, like a ramp. Like if you had a bike and you were riding up a ramp. See this yellow one? That is one of the sides, okay? And that one is 8 by the hypotenuse. Now, we didn't do the hypotenuse. We need to do it now. So it's 4, 4 radical 3, and of course, double the short leg to get the hypotenuse. So this is also 8, which makes this yellow thing a square, which we didn't know beforehand, but now we do know. They didn't tell it to us, we just kind of figured it out from this right triangle. So that's 64, right? That's 64. That's the slanted ramp side. Okay. Then there's, let's see. Then there's this whole back section here. I know it's going to turn to green here because I used yellow before, right? But there's this whole back section there. See that? That's another side. And that is 4 by 8. Very simple. It's a rectangle. So we're going to just do plus 32. Plus 4 times 8, right? Plus 32. And then finally, I'm not going to highlight it. It's the bottom piece here, right? In other words, the whole bottom here, 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 here. This whole area here. It's not the yellow because that's the slanted one. It's the whole bottom here. And that's 4 radical 3 times 8. It's 8 from there to there. 4 radical 3 times 8. So that's 32 radical 3. Okay, now here's the tricky part, or slightly tricky part, is we have to simplify and we have to add like terms. So 2 of these become 16 radical 3, right? So this whole thing, when you double it, is 16 radical 3, but you also have a 32 radical 3. See? So 16 radical 3 plus 32 radical 3. It's like saying 16x plus 32x, right? You leave the x's alone and you add the numbers because it's adding. So 32 radical 3 plus 16 radical 3 is 48 radical 3. And then we're going to add these numbers, which is plus 96. And that's the answer. We usually put the number first and then the radical second so that we don't have any mistakes after the radical symbol. You don't have to. This would be completely acceptable. But on the answer key, for example, the teachers probably did put 96 plus 48 radical 3. Doesn't make any difference in this case. It's just better form to... Squared, by the way, don't forget that. You want to get these right. Cubed for volume, squared for surface area. Okay, that wasn't every single problem, but it was most of the problems on both of the 9-R sheets. As I mentioned in the other video, all the rest of them are available online, on the drive, all solved for you with steps. So no excuse not to get a very high grade on Monday's test if you take the time this weekend to practice all of these problems. Good luck. Talk to you soon. See you Monday.